multiplexer using Verilog. Okay, so before going for the code, first you have to understand how the circuit is functioning. So what's meant by multiplexer? It is used for selection purpose. When you give many data, it will select only a particular data based upon the given condition. So hence it is also called as data selector. So this is an example using Verilog. So our objective is to design a 2:1. It means the number of inputs are 2 and the number of output is 1. So in this diagram you can see the inputs are named as D0 and D1, and the select signal is named as S, and the output is named as Y. So these are considered as the inputs and the output of the given circuit. Okay, so in apart from this one, you can see there are two AND gates, and we have not labeled the output of the AND gates. And similarly for the select signal also, we have not named the output generated by the select signal. It is nothing but an inverter. So those internal connections are called as wire. So here we are going to mention them as wire T1 and T2. These are the wires generated by the AND gates. Similarly, S bar is a wire generated by the select signal input S. Okay, so now our objective is we are going to write a code. So how many gates are there? There are 4 gates. So first we have to declare the entire coding as module name, then input output declaration. So apart from the input output, here we need to declare the wires also. Then we have to tell about each and every gates. Okay, so let's see for the code. So module name, output comma input, and you can see wires, we should not mention wires in the input output list. So there are 3 inputs, D0, D1 and the select signal S, and the output is Y. Wire of the 2 AND gates are T1 and T2, and S bar is the output of the S. Okay. So then we have the codes like AND G1 output comma input, AND G2 output comma input, or G3 output comma input. Okay, so here we have not included the S bar. So S bar is nothing but you can consider as G4 output comma input. Okay, so I will copy this code, execute this in modern shell. Okay, I am saving. After saving, what we have to do? We have to do for compilation. It was successful. Then we have to check the logical error. So compilation error is nothing but it will check only the syntax error. So now we are going to do simulation. So our model name is MU. Okay. So next step, we have to add the waveform. Okay, so check the code. The inputs are D0, D1 and S. D0 is 1, D1 is also 1. You can see here the values will appear here. A select signal is 0. Okay, so no need to give any value for the wires. Okay, so first, okay, initially these are the declaration. Next step is we have to check the S bar value. So S value I have given as 0. So S bar we have to check. See, in coding point of view, you have to check the line by line, then only you will not get any confusion. So I am running this. Okay, so first step is we have to check the S bar. What is the value of S? It is 0. So S bar is just a NOT gate operation. Okay, after seeing the, now we got D1 S bar D0. Then we have to check the T1 and T2. Okay, T1 is nothing but, okay, T1 is nothing but D0 and S bar. D0 and S bar. D0 value is 1, S bar value is 1. So when you do AND gate of 1 and 1, T1 will be 1. Next T2. T2 is nothing but D1 and S. D1 is 1 but S is 0. So T2 will be, and as it is AND gate and one of the output is 0, the output will be 0. So T2 will be 0. You can see here T2 is 0. Okay, now we got T1 and T2. It is OR gate. So T1 value is 1 and T2 value is 0 as per the condition of OR gate. If any one of the input is high, output will be high. So we shall check what is the value of Y. So Y value is 1. Okay, so now we can check the data flow. We can check the RTL schematic. So to check the RTL schematic, you have to do add to data flow all items in decide. Okay, it is showing only for the particular value. So this line AND gate and the next this S bar. Okay, so now we are going to change the value of D0 as 0. So force 0. Okay, I am running it 2 times. Okay, so D0 is 0, D1 is 0, S is 0, S bar is 1. So first we have to check the T1 value. D0 is 0, so T1 will be 0. T1 is, here you can see it is 0. Okay, D1 is 1, S is 0, so T2 also will be 0. T2 is also will be 0. Now T1 is 0, T2 is 0 as per the OR gate. So both the inputs are 0. So both are low. So output will be low. So Y value will be 0. So that's all about the 2:1 multiplexer, implementation of 2:1 multiplexer in Verilog. The next slide we can see the how we can implement the 4:1 multiplexer in Verilog. So in while implementation of 4:1 mux, there are 2 ways. Either you can call this 2:1 mux 2 times so that the number of inputs will be 4, or instead of 2 gates, 2 AND gates, you can directly mention 4 AND gates and select signal will be 2 select signals. So the condition of select signals is for 2 power n inputs, select signal will be 1. Okay, so here it is 2 inputs are there. 2 inputs is nothing but 2 power 1. So here n value is 1, so select signal will be 1. If it is 4:1 means select signals will be